Hi, good morning, good afternoon, everyone. So, my name is Jitendra Singh. I'm working as a senior software engineer at Microsoft. Prior to that, I was working with IBM Labs India, and this idea have been developed my tenure at IBM. So, let's get started. So, today I will be talking about. Today I will be talking about computational observability on Kubernetes and how it is helpful to protect our observability data in Kubernetes environment. So let's talk about the agenda which I will be running through today. So I will be first start with the current observability challenges, right? What is the challenge we face in traditional observability, right? And then we talk about what is confidential computing. Okay, let's keep it aside. I'll talk about it, and then I will talk about confidential containers. Okay, and then I will be talking about the solution. Okay, how traditional observability is not sufficient, about the pros and cons, and then how we are proposing solution which is called confidential observability. Then I'll talk about the architecture, how the data goes flow from observability pipelines, and then how we are making sure that it's secure, and then few key takeaways. So without further ado, let's get started. So at traditional observability, how does it look like? Yes, we have few applications which are generating logs, and then you have collected Fluent agent which collect those logs and do the processing and then send to the Elasticsearch for storage, and then Kibana can visualize it. Okay, this is how it looks. Okay, it's fine. Now let's talk about what happens if you have some sensitive data information in your logs. For example, you have user identification, you have tokens, you have internal metadata. Are these getting taken care while the whole observability data processing, right? Let's talk about it. Okay, so when we say data is getting collected, yes, from the follow encryption, okay, and then do the processing and then send to the Elasticsearch. But what exactly happen when it's actually doing the main processing of data? Okay, so when it's processing the data, it has to decrypt it. Okay, that time data can be exposed. So when we are saying that data in rest or data in transit is actually full encryption, no, that is not, because the data when it's getting used, it has to be decrypted and then only it can be used. That's where data can be exposed. Okay, and this picture is actually depicting the same information when character has already collected data and now it being processing, right? That time data can be exposed, and that's where if you have any sensitive information, the data is vulnerable and it can be exposed to any vulnerable content. Okay, now let's look at the other aspect of it, right? So when we understood, okay, there are few challenges that data can be exposed. The other thing is could be how we can limit those exposure. For example, we can making sure that okay, our log or our observability data can be exposed to only tested users. Okay, or how can I comply with some regulations, right? So that our sensitive data can be taken care accordingly, right? How we can making sure that the entire telemetry pipeline is sensitive, is dealing sensitive data is actually secured, right? How can I follow the safety measures and dealing with the data? So these all challenges comes in when we talking about in traditional observabilities, right? Of course, we need to have some solution to deal with it. Okay, that's where the term called computational computing. Let's bear with me for a few more slides. Then I talk about the problem which we see in traditional observability. So, what is computational computing? So, let's talk about the very famous encryption scenarios which we have data at rest, means data is securely kept and encrypted. Nobody can access it. Yes, it's fine. Now comes data in transit. You're transferring data from one source to another source. You're following TLS guidelines, doing encryption. Everything is fine. These are securely placed. Now, what happens when data is actually getting used? Okay, you transmit the data at some place, and now it is decrypting the data and using it. That time the data can be exposed when the data is in RAM. Okay, so those aspects we are not covering here in fundamental encryption types. That's where it's called new type of data encryption technologies, data encryption methodology, I will say, not technology, because we are talking about the keywords of computational computing, right? So let's look at it. How does it solve the problem, okay, of data in use encryption? Now we understood, okay, the confidential computing is talk about the data in use. Okay, how the flow looks like. Okay, so suppose that this diagram talk about how data is coming from application user. Application users try to access some data through some website or something. It has been encrypted under data in transit. Now it comes to application, okay, which is now decrypting data and then start processing it, and then maybe it's sending for in database. Okay, so we need to make some boundaries. Okay, we can make some isolated secure boundaries when data is getting used. Okay, if you see the green rectangle, that's where it's depicting the information that when you are using the data, it has to be securely isolated, right? That's where the concept of coming confidential computing. Okay, so it is providing some kind of isolation using hardware based isolation. I will talk about it. And it is making sure that data is not getting exposed outside of that boundary. Okay, so now we understood that confidential computing, what it provides some kind of confidential isolation. Okay, only the data in that boundary can be accessed and cannot be exposed to outside the boundary. Okay, so let's look at these few key points. So when we talk about confidential computing, it has to back by some hardware. Okay, so we have few hardware available in market. Intel TDX and AMD also has, and there are few other vendors as well which provide trusted execution environment. Okay, which is called TEE. So they are providing hardware-based isolation, hardware-based encryption. Okay, so when you creating any VMs or any node you on that hardware, the data will be securely managed by those isolation. Okay, and then we have key management services. Okay, which is taking care of key exchange over through that trusted execution environment, and then we run confidential compute containers on it. So let's talk about what is the confidential containers. Okay, so when we talk about confidential computing, okay, now let's understand how we can achieve this confidential computing concept in Kubernetes environment, right? So that's where I was talking about these key points. You have hardware, okay, and now you have created your nodes, and now you have your Kubernetes cluster. So when you deploy your workload, you have deployed your containers, right? How those data can be securely placed. Okay, that's where concept comes in picture is called confidential containers. So confidential container actually it's a simple container which runs a VM inside it, and that VM is aligned with the trusted execution environment. So all the data is which is getting exchanged under the boundary which I showed in previous slide has to be securely placed. And that's how we achieve that confidential observability. So all the logs will be fully encrypted, starting from hardware till the observability pipeline. So everything will be taken care and securely placed using the hardware-based isolation. Now let's look at this diagram where we are talking about how we are providing end-to-end encryption, end-to-end confidential observability. So if you see those pods, Fluent Bit pods and OpenTelemetry pods and Elasticsearch pods running under a green square, which we are calling is as a confidential containers. So those pods are running under confidential containers. So whatever data they're exchanging, this cannot be exported outside of this green rectangle. Okay, even if somebody try to access it, if you see the even admin cannot see the logs, they'll not able to see the logs. It will be all encrypted. Only if the request come through key broker service, and then key broker service will be request for the proper key, and then it has to go to the attestation service. So attestation service will be taking care that okay, you are the authorized person, and show me your authenticity. Then only it will allow you to key exchange. Then only the data can be decrypted. Then only data can be exposed to the user. Okay, so in any case, data outside of this boundary cannot be accessed by anyone, either even admin or anyone can access. If any pod try to access it, it cannot be exposed because the attestation service will not provide the authorized access, and these are all backed by the hardware. Okay, and that's how we achieve the confidential observability. The data is getting protected end to end. Okay, from application pods until the data getting stored in the Elasticsearch and getting processing when we're talking about data in use. Now let's talk about the two scenario which we talk about, the traditional observability and the confidential observability. Let's compare side by side. Yes, we talk about we in case of we are dealing sensitive data. In case of traditional observability, we can be exposed when we are doing the processing and collection. In terms of confidential containers, confidential backed observability, the data is fully secured, starting from data in transit to data in use and data at rest. So that's how we achieve end-to-end encryption in telemetry data. Now let's talk about where this can be useful. Okay, obviously the organizations which are dealing with sensitive data, specifically government, healthcare, and finance. Okay, and banks. So they has to make sure that they are aligning with some regulations. Also, the data cannot be exposed to anyone. Okay, this is very beneficial for these kind of customers as well. And obviously, when we talk about logs, right? Everybody think about data at rest is securely stored. So we are, we are good, but we are not talking about the data in use. That's where this confidential observability fill the gap. Now I can leave you with three key takeaways. Okay. So first of all, the data in transit, data in rest is not sufficient. We are talking about new aspect of that, data in use. That's where confidential observability is helping us. The second thing is that if anyone try to access, okay, those data outside of those secure boundary, cannot access data at all. Okay. So all your pods, Fluent, Loki, Elasticsearch pods are delivering end-to-end encryption data. And the third one is that with the help of confidential computing, confidential containers, we can achieve the end-to-end pipeline of observability, right? So, yeah, that's all from my end. If you have any questions, please reach out to me. I have leave some references over there from where I clear the details. Thank you for attending the session. Have a good day ahead.